Here we need to select the alcohol, the substance with a formyl group, and an unsaturated species. These are the compounds given to us. An alcohol must contain a hydroxyl group. The carbon to which the oxygen is attached must not be bonded to any other oxygens. Alcohols have the general formula CnH2n+2O. Compounds that have a formyl group are known as aldehydes. They have a carbonyl group near the end of the molecule, and to this is attached a hydrogen. An unsaturated compound refers to a hydrocarbon substance which contains at least one multiple bond between carbon atoms, that is, a double or triple carbon-carbon bond. Let's analyze each compound to find the alcohol, the formyl group, and the unsaturated molecule. If we analyze the structure for compound A, which is shown in full in the paper but slightly condensed here, we will notice it has this functional group at the end of the molecule. This is an aldehyde functional group or formyl group. So already we can deduce that compound A contains the formyl group. Then, looking at compound B, which is slightly condensed here, we will notice it contains halogens. This compound is a haloalkane, and since it contains alkyl branches, it is a branched haloalkane. For compound C, we are given a name, butanone. The suffix -one indicates we are dealing with a ketone. Butanone is a 4-carbon chain ketone. Ketones contain a carbonyl group, which is a carbon double bonded to an oxygen. Compound D shows the molecular formula of a compound, C4H10O. This formula has the form CnH2n+2O, where N is equal to 4. Since the molecular formula matches the general formula of an alcohol, compound D must be an alcohol. Note, however, that a class of compounds called ethers have the same general formula as alcohols. So the molecular formula for compound D could represent an ether. But if compound D is an alcohol, there are several possible structures we could draw. It all depends on the branching and on which carbon the hydroxyl group is. Here we have drawn just one of the possible structures. And this is the hydroxyl group. Then we are given the condensed formula for compound E. If we expand the condensed structure a bit, we will notice there is a carbon-carbon triple bond. And so this compound is an alkyne and is therefore unsaturated. Compound E is unsaturated. Let's finish by checking the other compounds to make sure we haven't missed anything. We are also given the condensed formula for compound F. Expanding this formula a bit, we will notice the COO functional group appears between two carbon atoms, which tells us this compound is an ester. Then the molecular formula is given for compound G, and it has 2 oxygen atoms. Possible functional groups which contain 2 oxygen atoms include carboxylic acids and esters. Compound H is shown in a condensed formula. This is its structure, and it contains only carbon and hydrogen with single bonds between all the carbons. So it is a saturated hydrocarbon. Specifically, it is a branched alkane. Finally, the alcohol is compound D, the formyl group is found in compound A, and compound E is unsaturated.